In the last section, we took care of our shuffle function by relying upon some functionality that was implemented in the Dart standard library. We're now going to move on to our next function, which is cards with suit. Let's take a look at a diagram that's going to give you a better idea of the purpose of this function. So I want you to imagine for a second that maybe we have this deck of cards shown at the top. So ace of diamonds, 2, 3, and then ace of spades and 2 of spades. If we call the cards with suit method on the deck class and pass in a string of spades, then I would expect to receive a list back to me with the ace of spades and the 2 of spades. So essentially go through the deck and find all the cards with a particular suit. Now, one thing I want to mention here is that we do not want to modify the original deck of cards. So we're not trying to pull cards out of here. I just want to get a list telling me all the cards with a particular suit that still exist inside the deck. Okay, so let's go back over to Dartpad and we're going to start our implementation. So back over here, I'll find my deck class. I'm going to add a new method to this class down at the very bottom of the class itself. And I'm going to call this cards with suit. Now, as we just saw in that diagram 2 seconds ago, right over here, we clearly have to pass in a string that indicates what suit we're trying to find. So I'm going to make sure that I mark this method as requiring one argument that we will refer to as simply suit. So now if you want to call the cards with suit method, you have to pass in some suit argument. One thing I want to mention here is that if you click on suit and then look down at the type on the bottom right hand side, it says dynamic suit. The word dynamic here means that Dart is not able to figure out what type of variable suit is supposed to be. So this is a good example of where Dart's going to try to figure out what's going on with your code, but it's not quite able to. Anytime Dart does not have enough information to figure out what your code is trying to do, I recommend annotating your values with a type. We've already done this a couple times inside of our project already. You'll notice that, say, on the card class right here, we specifically marked this suit as being type string, and that gave Dart enough information to figure out what type the suit property was supposed to be. But in this case, we don't have enough information, and so I'm going to specifically mark this argument as requiring to be of type string. So I want to make sure that if you ever call this cards with suit argument, you pass in a single argument that is a string. So to do so, I'll write out string and then suit. So now if I click on suit again, you'll notice that it says string suit. So we've now given Dart enough information to figure out what type of variable suit is right here. Okay, so now that we are inside of our cards with suit method and we have the appropriate type of argument, we can now write some logic to go into our list of cards and find every card with a given suit. Now you might be thinking that we're going to have to put together a for loop or something crazy like that and iterate over all the cards within our deck. But rather than doing that, we're going to again rely upon the Dart standard library, particularly some functionality that we get with every list for free. So I'm going to again pull up the list documentation. Remember, you can get here by going to api.dartlane.org. And then you'll look for the Dart core module right here. And then you can find the list section on the right-hand side. So once I'm back here, I'm going to scroll down towards the very bottom of the file. So all the way down here, right above the operator section, I'll find a method called where. So the where method right here is going to return a new lazy iterable. Let's not worry about what a lazy iterable is just yet. It's essentially kind of something like a list. But more importantly, it says that it's going to return an iterable with all the elements that satisfy some given test. So we're going to make use of this where method right here to automatically iterate through all the items within our cards list and only return the items that satisfy some test that you and I are going to write. So let's take a pause right here. We're going to come back to the next section and we're going to start our implementation of this where method. In the last section, we started talking about how we're going to use the built-in function where that belongs to every single list that we create to automatically walk through our list of cards and return every card with some given suit. So I'm going to flip back over to Dartpad, and we're going to start our implementation inside of the cards with suit method that we added. So inside of here, I'm going to reference the cards property that exists inside of every deck we create. And then on this cards list right here, I'm going to call the where method. We're going to just write out the entire implementation of this method right here, and we'll talk a little bit about how it works. So inside of here, I'm going to place another set of parentheses, and then I'll write out the word card. Then outside those parentheses, I'll add a set of curly braces. And then inside of there, I'll put return card.suit equals suit, like so. Okay, so let's talk about what just happened here. When we call cards.where, we have to pass in a function. So that's what this is right here. We defined a function without a name, and we passed it in to the where method. The where method then takes this function, and it runs that function one time for every element within the cards list. So every single card within the cards list is taken and it's passed to this function as the first argument. Then inside that function, you and I have to write some amount of logic that returns a Boolean. If we return a Boolean value of true, then that value is retained. Otherwise, if we return false, then it assumes that no, we don't care about this element. So we are looking for every card within our cards list that has some given suit. So we looked at the card.suit property, and we said if this thing is equal to the string suit that was passed in to our method here, then we want to keep that card around. Okay, so that's how this where method right here works. Now the last thing we'll do is make sure that whatever gets returned from cards.where gets returned from our cards with suit function as well. And so to do so, we'll just add on the keyword return right before it. Okay, so let's now try testing this out inside of our main function. So I'll scroll up to the top, and let's leave the shuffle in, what the heck, and then we'll print out the result of deck.cards with suit, and notice how we now get this nice autocomplete here with a function that you and I added. So we'll call this thing, and I'm going to try to get every card with a suit of diamonds. All right, so now I will run this code, and we'll see what happens. Okay, just going to give it a minute. Let's try it one more time here. There we go, much better. So I now get 4 of diamonds, 5, 2, 3, and ace. So clearly we went through that list and we pulled out every card with some given suit. Now one thing I want to point out here is that rather than the square brackets that we had before, we now have a set of parentheses. So if you go back over to the documentation for that where method, you'll notice that it says that it returns a new lazy iterable. So an iterable is something that is like a list, but not quite a list. We're not going to make a big distinction between the two just yet, but this is a topic that we'll come back to later in the course. For right now, I really just wanted to show you how to make use of the standard library and how to use some of the built-in methods that exist on lists already. Okay, so that looks good. So let's take a quick pause right here, and we'll come back in the next section. In the last section, we put together our cards with suit method, and we made special use of the where function that is included with every list automatically. In this section, we're going to do a very small refactor to this function right here to make use of an abbreviated syntax for defining functions. So I want you to notice right now that when we call where, we passed in a function that gets called one time for every element in the array. And we used what is referred to as the long form function syntax right here. The long form function syntax makes use of these curly braces. And we also had the return statement in there as well. Notice how the body of our function really just has one single expression inside of it. And this single expression just looks at one property and compares it to another. So this is one single expression. Because we have one expression inside of here, we can use a slightly abbreviated syntax for defining this function. So we're going to do the refactor, and we'll talk about the differences between the two. So I'm going to first get started on this refactor by removing this semicolon. I'll then remove the return statement, and I'll put all this stuff on one line, like so. I'll then remove this curly brace on the right-hand side, and then I will replace the curly brace on the left-hand side with an equal sign and a greater than sign, like so. Oops, did not mean to click that. There we go. So what we have on the screen right here is completely equivalent to what we had before. So because we had one single expression, we can make use of this arrow function syntax. If we had multiple expressions or multiple lines of code, we could not use the abbreviated syntax. The other thing I want to make clear is that when we use this arrow, we get what's called an implicit return. So whatever this expression right here evaluates to will be automatically returned from the function before us. When we had the long form syntax with the curly braces, like so, we had to manually put in a return statement. So because we had a single expression and we made use of the arrow syntax, we got an automatic return for free. So if I now run this code again, you'll notice that I get the same result up here on the top right, just like I did before. We're going to be making use of this abbreviated syntax quite a bit throughout this course, and we'll sometimes also swap off back to that longer form syntax anytime we need to have multiple expressions inside of our function body. So we're going to see the syntax quite a bit both ways. All right, so we've got a good refactor here. Let's continue in the next section.